IPv6 turned 25 in December. And for those of you who've passed that milestone yourself, you probably remember your friends saying, wow, 25 years, that's a quarter of a century. That's a really long time. And you know, it is kind of. So I thought it would be kind of fun on IPv6 25th birthday to take a look at how far it's come, and that while IPv6 might not be where the architects thought it would be at this point, it certainly has come of age, and it has inserted itself firmly into the internet. So let's start out by taking a trip down IPv6 memory lane. The protocol began in December, officially in December of 1995, when the RFCs were released to propose it as a solution to IPv4 address exhaustion. And the RFC 1881 was the address management allocation, and the RFC 1883 was the protocol specification. And from that point, IPv6 was off and running. In 1999, ACNIC, ARIN, and RIPE were allocated their first /23s so that they could give users IPv6 blocks. Microsoft added IPv6 stacks to both of its operating systems in 2001. And Hurricane Electric actually took advantage of that ability to get an IPv6 block in 2001 as well. In 2002, LACNIC became the fourth RIR to get a /23. By 2003, Sprint was deploying IPv6, and then Apple had added IPv6 support to its operating systems. In 2004, Afrinic became the fifth and final RIR to get its /23, so now every RIR could give IPv6 allocations to anybody who wanted them. In 2007, Hurricane Electric converted its network to native IPv6. In 2008, the US government announced that it was IPv6 capable across all of its systems. And the European Union also set the goal for having all of its systems, or 25% of its systems rather, IPv6 capable by 2010. Google Search and Maps were available over IPv6 in 2009. And by 2012, we finally get to World IPv6 Launch Day after 17 years on June 6th. Trying to encourage IPv6 adoption. And then in 2017, we got the official IETF ratification of IPv6 as an internet standard. So that's what is where it's been in 25 years. Now, I thought that a talk on IPv6 was not going to be complete unless we talked about why it's not IPv5. And actually, for those of you who know, there is an IPv5. It was known as the Internet Stream Protocol, or ST, and it was designed for connection-oriented communications across IPv networks. But IPv5 was based on the 32-bit address scheme, so there was no way it was going to be a successor to IPv4. But the concepts in ST are similar to later asynchronous transfer mode protocols, and its concepts can be found in MPLS. So it didn't exactly go away, but that's the reason why it's IPv6 and not IPv5. So let's take a look at the IPv6 adoption rate. V6 has come a long way since it debuted, and I thought I would look at how many of the world's internet users are routed over IPv6 and what the IPv6 routing table growth looks like when you compare it to IPv4, and how access to the internet is driving adoption of IPv6 globally. So first, we're going to start out by looking at the adoption rates over various countries. Now, there are a couple hundred countries in the world, and this would be a very busy graph if I put them all in there, so I decided to put just the top 50. And you can see that adoption ranges from Belgium, which is a little over 55%, down to Nepal, which is about a little over 12, and then everything in between. You can see it's kind of an eye chart, and you probably can't see all of the countries that are on here. But I thought it would be interesting to point out the countries that weren't, which are Russia and China, which, despite having large populations of internet users, do not have a high adoption rate of IPv6. Let's look at the top 10 countries that have adopted IPv6. Belgium is in first place. And when you think of Belgium, you probably do not think of IPv6. You probably think of waffles and beer and maybe chocolate. But it's not an accident that Belgium is first place. They have a very active IPv6 council, and they had experienced an early shortage of IPv4 addresses. So it was, with a country with 11 million people, they had to do something, and they began consistently topping the list of countries that adopted IPv6. India is in second place, and India also is a country that had a lot of people and not very many IP addresses. Sci-Fi Technologies rolled out IPv6 in 2005. So that's the reason why they're in second place. They've been using it for a long time to cope with IP shortages. Germany owes its place on this list mostly to aggressive deployments by its ISPs, both in mobile and Wi-Fi. Telecom Malaysia, same thing, mobile deployments. Greece, another country you might not have thought would be on the top 10, but it has consistently been in the top 10 countries adopting IPv6 for the last 5 years. Taiwan has also is not a surprise. It's a densely populated country, and it just rolled out a large mobile deployment and landline deployment with IPv6. So that's the reason why the percentages are so high there. Vietnam has been steadily inching its way into the top 10 for years. It finally made it the top 10 in 2019, again, mostly due to mobile deployments. The United States owes its position on the chart mostly to ISPs like Verizon and Comcast and AT&T, who rolled out their deployments either to their end users, their residential networks, or to their mobile networks. Luxembourg and Switzerland are both at about 44%, and again, a shortage of IP addresses and aggressive deployments are how they got there. So if we look at IPv6 growth over the last decade, or route table growth of the last decade, well, let's start with IPv4 because we're probably familiar with that. In 2011, we had about 341,000 routes in the IPv4 table, and we're up to like 860 or so at the beginning of 2021. And so that's, quite a bit of growth over the last decade, a lot of routes in IPv4, everybody knows that. So let's look at how IPv6 is done. Now, it started a little more modestly in 2011 with 4,200 routes. And actually, when it was having its birthday in December, it also passed 100,000 routes. That was a big milestone for IPv6. So at this point, there's about 105,000 routes in the table. And you can see from the growth curve, it looks, that's pretty good growth curve. So then I thought, well, that's what happens when I just pop those two together. And, then IPv6 doesn't look like it's doing as well as IPv4. It looks kind of small, but, is it really? Let's look at the percentages instead. So if we look at the percentage growth per year, it kind of tells a little bit of a different story. You can see that it had quite a large percentage growth the first year of almost 85%. But the IPv4 table has been growing between 5 and 15% over the last decade, whereas the IPv6 table has had at least 25% growth every single year over the last decade. And to really bring home what that means, if we show the year-over-year percentage increases of IPv6, now you can see how this really has grown. And it kind of turns the table on that other graph. We have 388% of growth over the last decade in IPv6 versus about 97% in IPv4. So I know what you're thinking. You're probably saying, Susan, yes, this is, a lot of growth, but, it took IPv6 25 years to get to 100,000 routes. Well, does anybody out there remember how long it took IPv4 to get to 100,000 routes? Well, I do. It happened in 2001. Now remember, IPv4 was released to the public in 1981. So that means it took IPv4 20 years to get to 100,000 routes. And remember, from our little trip down memory lane, IPv6 didn't even get released to the RIRs until 1999, which means that it took about 21 years for IPv6 to get to get to 100,000 routes. So that's not really that different between the two of them. So it looks, that's pretty good performance. Now, if you really want to understand why we need to adopt IPv6, you need to look at the world population, because the world has 7.6 billion people in it, and about 60% of the people have internet, and about 40% don't, which means that there is 40% of the world that is still going to need an IP address. So to understand how that works, if you look at the global internet increases over the last 15 years, it's helpful to look at it in terms of your users worldwide, which is the blue line, and then users in the developing world, which is the orange line, and users in the developed world, which is the green line. And you can see that the developed world has gone from about 51% to about 87%. But the users in the developed world have gone from about 8% to 52%. And it's important to look at it this way, because if you can do the math, it's very apparent that there are obviously a lot more users in the developing world than there are in the developed world. And there's a lot more people that need to be onboarded onto the internet. Now, if we take that and we do a year-over-year percentage increase of that, you can see that the developing world actually is starting to grow and starting to access the internet at a very accelerated rate. So a lot more people in the developed world are getting onto the internet, and they're going to need IP addresses, and they're not going to fit in what's left for v4. So now that we've looked at how the IPv6 has grown and how many addresses are needed, I thought it was a little time to take a look at IPv6 security. And it turns out that IPv6 is not only outpacing IPv4 in the address tables, it's actually also leading the way in RPKI adoption. As you know, RPKI is a crucial tool in preventing leaks and hijacks, and the number of IPv6 prefixes with ROAs is outpacing the one of IPv4. So let's take a look. If we look at the global tables in January, just last month, we can see that that IPv4 prefixes with ROAs with valid ROAs are about 26%, invalid about 1%, for a total of 27% of those IPv4 prefixes with ROAs, whereas and 73% without. But in IPv6, we've got 31% with valid and 1% with invalid, for a total of 32% of prefixes that have ROAs for IPv6. That means that it's being adopted at a lot faster rate. And you don't go to the trouble of making a ROA unless you're actually going to use it. So, that does speak pretty highly of the importance of IPv6 as far as security goes. So let's look at IPv4 versus IPv6 as far as how much of the internet they take up. It's important to understand how much each RIR has of the percentage of the prefixes in the internet to understand where the work needs to be done. Afrinic has about 3.7% of the IPv4 addresses and about 1.3% or 1.13% of the IPv6. APNIC has about 23% of IPv4 addresses and 28% of the IPv6 addresses. And ARIN has 37% of the IPv4 addresses and 22% of IPv6. LACNIC has about 10% of IPv4 and 21% of IPv6. And RIPE has about 25% of IPv4 and about 28% of IPv6. So this is how the addresses are distributed. Now, if we look at, for IPv6, we're trying to figure out where this work is to be done. We can see that in Afrinic, even though they only have 1.1% of the internet space, the IPv6, they have 22% of that space in ROAs. So actually, Afrinic is doing really well as far as creating ROAs for its IPv6 space. APNIC has 30% of its space in ROAs, and it comprises 28% of IPv6 space in the internet. ARIN has 18% of its prefixes in ROAs and has 22% of the space. LACNIC has 29% of its space in ROAs, and RIPE has 46% of its space in ROAS, and both LACNIC and RIPE have 21 and 27% of the space respectively. So what that tells you is that RIPE is actually doing the best job of all the RIRs getting ROAS for its prefixes. ARIN is it's probably doing the worst because it has the lowest ratio of ROAS compared to the amount of space on the internet. And it means that there's a lot of work to be done in ARIN as far as making ROAS. If we look at the percentage of IPv4 and IPv6 with ROAS, you can see that Afrinic is actually doing a lot better for IPv6 than IPv4. They have about 8% of their IPv4 prefixes in ROAS and 22% in IPv6, 29 versus 30 in APNIC, 14 versus 18 in ARIN, and 35 versus 29 in LACNIC, and 42 versus 46 in RIPE. Again, RIPE's doing great in all categories. ARIN is doing even worse in IPv4, unfortunately, because it has 37% of the world's IPv4 space and only 14% of that is in ROAS. So if the amount of prefixes in ROAS is going to increase dramatically, a little bit of work needs to be focused there. Now, when I was doing this talk, I was talking to my colleague Anurag, and this was what I've been talking about IPv6 and IPv4 ROAS for a while. And after I was talking to him about the amount of people that had ROAS and IPv4, he decided to go take a look in India and see how many of the prefixes in India had ROAS and IPv4. And when he looked in July, they only had 13%. Now, Anurag belongs to a NOG called India NOG, IN NOG. And he is actually the co-chairman of the program committee. And he thought, you know what, I'm going to go talk to my friends and see if we can make things a little bit better. And so they went out and started evangelizing creating ROAS because they thought that India shouldn't be at 13% when the global average at that time was about 24%. So in October, he came back to me and he showed me these numbers where India had increased the amount of IPv4 prefixes in ROAS to 31% with valid ROAS plus one, so 32% of its space versus 68% not. Dramatic increase. That's a great deal. And I was really impressed. And so I asked him, I said, well, what's your IPv6 space like? Well, it turned out that it was about 10%, and which wasn't very good. But Anurag decided that they might be able to do better on that too. So they went out, and these are the results for February. They're up to 42% of their IPv4 prefixes in ROA and 41% of their IPv6 prefixes in ROA. And you have to realize that this is not a small effort. It's not like they could just go out to one ISP and get them to put their prefixes in ROAS and everything will dramatically increase. As you saw, IPv6 is, a big deal in India. It's the second largest deployment of IPv6 in the world. And yet they were able in the space of 4 months to go from 10% of their prefixes in ROAS to 40%. So that's incredible. And if this were a live meeting right now, I'd be asking you all to stand up and give India a round of applause that they could hear all the way from Atlanta, where we would be, to India. But since we're not, you can't do that. However, it did make me think, if these people could do such a great job and had so much pride in their internet infrastructure that they wanted to make sure it was secured, we could actually do the same thing. And here's what it looks like in North America. We're going back to ARIN having 14% of its prefixes in ROAS and for IPv4 and 18% in IPv6. So how about it, people? Perhaps we could do the same thing as our friends over in India NOG and go talk to all of those networks out there and ask them why they are not putting their prefixes into creating ROAS for all of their prefixes. So it might be a good thing to start. So IPv6, 25 years. In summary, over 30% of the world's internet users are routed over IPv6, and this is steadily increasing. The IPv6 routing table growth is very healthy and outpacing IPv4, and internet user numbers are increasing at a rapid rate, and IPv6 is the only protocol that has room for them all. Thank you for your kind attention. Are there any questions?
Well, That was an awesome presentation. Not only can IPv6 drink, but it can do it everywhere in the world legally. We do have some questions in the Q&A queue, and I'm taking them out of order. So, first question. Have you seen cases where IPv6 can provide something IPv4 cannot in the enterprise? How to make a compelling business proposal to start deploying IPv6 in a medium-sized enterprise besides V4 exhaustion, education, and preparedness?
Well, I guess I could start by saying that I don't work in an enterprise, so I don't know that I am, I work in ISP, so I don't know that I am qualified to talk about how V6 can provide something in an enterprise that it can't, that IPv4 can't. But I can say that the compelling business case for IPv6 is what I was trying to point out in the talk, which is 40% of the world is not on the internet yet. And that means that when they get on, a lot of that percentage, that population is going to end up being on V6. And sooner or later, you are going to start seeing more users on V6 than V4. And when that happens, you do not want to be in a hurry to deploy V6. It's far easier to do it, slowly, deliberately, and carefully now, so that you have your deployment working exactly how you want it and all the bugs worked out of it before you get to the point where you're in a panic and you've got to deploy V6 or you're not on the internet. So I would say that is, one of the biggest things as far as, logistics and operations. But the second thing, of course, is that IPv4 space costs money right now. And if you can reduce your dependency on it, then you are going to have an advantage as far as the cost of operating your business.
Cool. Next question. This one is by Patrick, no last name. Isn't V6 table growth a bad thing? I thought the point was to hand each ISP a /24 and just have a few thousand prefixes total in the DFZ.
Okay, so I don't think it's a bad thing because the reality is that as more people get on the internet, you're going to need more addresses. So the prefix table is probably going to grow. I don't know if the IPv6 table will ever be as big as the IPv4 table, just because you can advertise a /32 on the internet or even down to a /48, and that's still more addresses than all of IPv4 put together. So so you're probably not, each network is probably not going to have to advertise as many IPv6 prefixes as they do IPv4. But I think that the important thing is that it would be nice if the IPv4 table weren't growing so fast and we were increasing our reliance on IPv6, because then we probably wouldn't be running out of memory on our routers so quickly, and it would be cheaper to operate our infrastructure. So going to V6 has an advantage there too. And then I think that, but I don't think that having a larger V6 table is a bad thing. Honestly, I think that when we get to the point where we have more traffic that's going across V6 than V4, that's when we know we've hit the turning point.
Okay, so let me extrapolate off of that. So if V6 does the right thing, then we'll be able to take those SOUP 720s and RSP 720s out of the closet, because the tables will be small enough that they won't blow up.
Well, if they'll route V6.
Actually, they will. It looks like we have time for two questions left. One is, do you agree with the 2017 published RIPE VCOP for V6 assignment to customers, which is RIPE 690, which has since been superseded, recommending a /48 for everyone? And what are your thoughts on providers which are doing a /64 instead?
Well, I know that like Hurricane Electric, for example, does /64s inside of its network for all of its customers, but you can request up to a 48 with most providers. I don't know that anybody that would deny you one. The 48, of course, can be advertised on the internet with, it doesn't have to have it's by itself. It's like the smallest prefix you can advertise in v6. So there's that advantage. I'm assuming that people who give /64s to the customers are assuming that those customers won't need to advertise those prefixes independently. If they do, then they should be given a 48. And I think that's the reason why most providers make that distinction, is that the space isn't meant to be multi-homed. If it was meant to be multi-homed, then of course, they could give a prefix large enough to advertise on the internet. So I think it's kind of just a matter of ISP policy, really, more than something that's right or wrong. It's you kind of hate to be the person that tells somebody else how to run their network.
I think I'm going to avoid the last thought there. I have one question for me, which is, what, in your opinion, is the backscatter of PCI consultants telling customers you can't use IPv6 and PCI, so you have to turn it off across your enterprise?
Well, I would say that obviously is wrong, because lots of large networks use v6 only, and lots of large content providers inside of our industry put all of their services across v6. So I would counter that if you're having difficulty making something work on IPv6, you probably just need to have a little extra engineering and fix it. But to my knowledge, there isn't an obstacle to put your service on IPv6.
Okay, that was devil's advocate there. So I think we're out of time at this point. There are a couple more Q&A in the session which you might want to answer directly there. Thank you very much, Susan. As always, a wonderful thing about v6.